this an improper integral?
Yes.
Yeah. What I'd like to do is graph what it is I'm trying to do. So we're going to get a geometric interpretation of this. What area are we trying to find? Here we have an idea. Now this is an improper integral. This is an integral that we're not allowed to do as far as the fundamental theorem of calculus goes. What I'm going to do is I'm going to rewrite this so that it is a proper integral, and then we'll figure out what we want to do from there. I'm going to come up with what's called a dummy variable somewhere within the boundaries, and let me use different color there. All my colors are my bit campus.
Mm-hmm.
I'm going to call that variable t. And I'm going to set up the integral, again, in such a way that, notice t is fine. I'm not dividing by 0 or doing anything crazy like that.
The limit.
Just copy it down, we'll talk about what it means.
It says limit.
Now it says limit. Natural log and limit in my world look the same.
With a dot.
With the dot. That's your indicator is the dot. Alright. So I'd like to focus on the integral first. Let's forget about the limit for a second. This says that I am integrating the function 1 over x minus 2 from t, I generalized t that's within my boundaries, to 5. Perfectly fine integral. No issues. Not a problem. After we do that integral, we are then going to take t and shove it all the way to 2. After we do the integral. So we've made it proper.
Where did the 3 come from? Oh.
So I plugged in 5, that gives me natural log of 3. If you want to keep the absolute value, that's up to you. Minus natural log, and now I put t in there.
Oh,
After we all do all the proper stuff. Yes?
The plus sign above the 2, is that just telling you you're going all the way to 2?
No, that means we're going from this direction. The negative would mean I'm going from this direction.
Okay.
I'm sorry, do you guys remember this symbol here?
No.
The superscript? Yeah. If it's plus, that means I'm approaching from the right, going left. If it's minus, that means I'm starting left and I'm going right. Okay. Natural log of 3, not an issue, right? That's fine. Now we have a couple things that could happen here. One, this limit could go to a specific value, and we're good. We would then say that the integral is convergent, meaning it goes somewhere. 2, it could not go to a specific value. It could go to infinity. It could go to, it could flip-flop between -1 and 1, something like that. If this limit goes to anything but a specific real number, we say that it's divergent. So let's take a look at this. So far, convergent, we're happy, yay. However, we're here. I want us to visualize what's happening here. T is approaching 2, which means this is approaching what?
0.
0. A couple things going on here. What happens to natural log as we approach 0?
Negative infinity.
It goes to negative infinity. But you just said negative infinity times negative. Okay. The natural log of 3 doesn't change, right, the infinity piece of it. That's nothing after 60 trillion. So this goes off to infinity. What does this tell us? What does this
Divergent.
tell us about the area? There's an infinite amount of area as we're going this way, which makes sense. There should be an infinite number of an infinite amount of area. So we would say that this is divergent.
Like it.
Yes,
Just that section or the whole?
the whole thing. Yeah.
Then divergent.
The word divergent means that it's not going to a specific place. The word convergent means that it comes together. So if you see 2 roads and they come together, you would say that they converge. This one is going off to infinity. So again, anything other than, this is a test question, it's one of your multiple choice questions, make note of this. If an integral goes anywhere except to a specific real number, then it's divergent. If it goes to a specific real number, then it's convergent. Even dumb it down even more. Not dumb it down. That's terrible to say. I don't mean that. I'll even explain further. Let's say that that limit went to natural log of 17. Is that convergent or divergent? It's convergent. That's a number, right? It's a specific real number. Just keep that in mind. Let's do another one.